All right, Bismillah, Assalamu alaikum. So, so today we start a new chapter, and so again, what we've talked about so far, I keep talking about these four classes of biomolecules, right? That you open up a cell, you find these four classes of biomolecules, which are called biopolymers, right? So biopolymers, and we said we're going to talk about one of each of them one by one, and the first one we talked a lot about were proteins, which were made up of amino acids. We did talked about a lot about them. Second one we talked about lipids, quite a bit actually. So we finished that as well. In the syllabus there are nucleic acids. So we're going to skip over that for the time being. So nucleic acids for the time being we're going to skip over that, and instead we'll jump to what I want to talk about are polysaccharides or carbohydrates. Polysaccharides uh, or carbohydrates. Carbohydrates, right? So we'll talk about that. We'll start talking about carbohydrates today, and then if you have time towards the end of the semester, we will see if we can come back to nucleic acids. But I believe you guys have seen nucleic acids quite a bit in your classes, basic biology, or a lot of you have taken biomedical engineering, so you're pretty familiar with nucleic acids. All right, so that's the plan. We talk about polysaccharides or carbohydrates. Um, and this is what we'll talk about. We'll talk about what we call them sugar structures. We'll talk about the stereochemistry. These are stereoisomers. They can be stereoisomers, and how we can represent them. There are two ways of showing them, as a straight chain or as cyclic compounds, and we'll talk about this hopefully today. And hopefully by the end of today we would have finished what are called monosaccharide reactions or monosaccharides. And then we'll continue with disaccharides and polysaccharides, as well as reminding you again the importance of carbohydrates and proteins called glycoproteins, as cell surface antigens, like blood type. Remember we talked about this blood type A, B, and A, B, and O. These are actually coming from the glyco part of the protein on the membranes of red blood cells. Anyways, so the plan is to actually finish this hopefully today. See how it goes. Okay, so it turns out there are basically three types of carbohydrates. We call them monosaccharides, and as the name suggests, right? So mono means one, right? So monosaccharides are just simple building blocks, and it's one sugar molecule. And then we also have um, disaccharides. Of course, disaccharides, as the name suggests, they have two things together. So two monosaccharides are linked together. And then there are a few examples of those we'll talk about, like sucrose and lactose. We'll talk about those as well. And the last class, as you can imagine, would be the polysaccharides, right? So we'll talk about which one of them one by one. Poly would be the chains of many monosaccharides linked together. Okay, so starting with monosaccharides. Monosaccharides are primarily, um, and they're also called simple sugars. So I think sometimes you hear the word simple sugars or polysaccharides. They are interchangeable, but so they really are. There are different ways of explaining them. Basic formula for monosaccharides is this: CH2ON. And when we say carbohydrates, so that's another interesting way. Oops. So if we say carbohydrates, right? Um, of course, the hydrate part means H2O, right? And the carbo means carbon. So it means that you have carbon and H2O, right? And you have many of those, right? So this really is what a simple clean this up a little bit. So this is really what uh, this is really what the general formula of monosaccharides or carbohydrates are, and N can be 3, 6, 3, 4, 5, 6. So for example, if I say CH2O 6 times, so if you multiply that, you get C6 H12O6, right? And this is glucose, which is a monosaccharide. Okay, so that's one definition, that these are hydrates of carbon, right? So you can say these are hydrates of carbon, or CH2O many times. That's one definition. Okay. The other definition that which is really important for us to understand is that monosaccharides or carbohydrates are polyhydroxy, aldehydes, and ketones or ketones. So they're polyhydroxy molecules, either aldehydes or ketones. What I mean by that, that these have to have many hydroxys, not just one, but polyhydroxy, and they have to be aldehydes or ketones. Now remember, we talk about aldehyde groups and ketone groups. Ketone functional groups, just as a reminder, are things that you have a carbonyl, right, with C and C. So that's ketones. Aldehydes are same. You have a carbonyl, you have an H on one side and C on the other side, right? So just please make sure you understand this is aldehyde, and if you have things like that, these are ketones. Of course, hydroxy, we all know hydroxy are things which is OH groups, right? So poly would mean more than one. Okay, so now let's see how they look. So we're looking for, of course, ketone, carbonyl, or you know. So for example, here, if I say this would be an aldehyde group, right? Okay. If I look at this, COOC, this would be a ketone functional group. Right? So please make sure you understand this. Now, if you look at this structure here, you find it has OH, it has OH, it has OH. So it has 1, 2, 3, 4 carbon compound. It has 1, 2, 3, 3 OH, so it's polyhydroxy, and it has aldehyde. So this is a sugar. This is a carbohydrate. This is a sugar. This is a monosaccharide. Likewise, if you look at this, you have one OH, one OH, one OH. Oh, great! You have three OH and a carbon, and then fourth one here, and then you have a ketone group. So this is also a simple sugar. This is also a monosaccharide. Okay. Now, what they're saying is, you know, you can name these monosaccharide based on these functional groups. What functional groups? So they have either aldehyde or ketones. So we can call them keto sugar or aldo sugar, right? So if it's ketone carbonyl, we call it a keto sugar or ketose, OSE, like glucose and fructose and sucrose, OSE, SOS. So it's a ketose or keto sugar. If you have an aldehyde functional group, we call them an aldo sugar or aldose. Aldose. So aldo sugar, we can call it, or we can call it more accurately aldose, or we can say keto sugar, or we can call them a ketones. Okay, so that's one way of naming them. And the other way of naming them is number of carbon atoms, how many carbons you have. So if you have 3 carbon, we call it triose, tri. And again, OS is always with carbohydrate like glucose and sucrose. Always you add the word OS. So the OS is really is good to keep in mind. This OS part, this OS part, this OS, right? Okay. So if you have 3, we call them triose. If you have 4, the word is tetros, like tetra. If you have 5, pentose. If you have 6, we call it hexose. If you have 7, we call it heptose, and that's you may see it later on. Okay, so here if you look at carbon, 1 carbon, 2 carbon, 3 carbon, this is a triose. Okay, very good. Now if you look at the functional group, we find it's an aldo, so it's aldose and it's triose, and you can combine these two things together, right? You can say it is an aldo triose, right? It's an aldo sugar and it's a triose, aldo triose. Here 1, 2, 3, 4, 5, 6 is a hexose, and is a keto aldo group has many hydroxy group. By the way, here you have 1 hydroxy, 2 hydroxy, so it's a dihydroxy, so that's why it's a sugar. If I had only 1 here, then that would not be a sugar, so it has to be polyhydroxy always. You have 1, 2, 3, 4, 5 is polyhydroxy. It's 6 is aldo, so it's an aldose, it's a hexose, and it's an aldo hexose. For the time being, don't worry about these names. We'll come back to them a little bit later. Here, 1, 2, 3, 4, 5, 6. Again, it's a hexose, right? It's a hexose. Look at the functional group. This is a keto functional group. There is no hydrogen attached to the carbonyl, so this is a ketose. It's a ketose. It's a hexose, and we can put them together and say it's a ketohexose. Okay, good. So I hope all of you understand this. So please keep an eye on this. Make sure you understand these things. All right. So moving on to the next one. the idea that these are stereoisomers. Now we talked about stereoisomers before, and we said stereoisomers are things that you have a carbon here that's attached to 4 different groups attached to them, and if that's the case, you can write them as a mirror image. So the C is close to the mirror, so I put a C here, and this A is further away. I put A here, and D would be here, and then B would be here, and these would be stereoisomers, right? And we call them mirror images. Okay, so stereoisomers, we all know them. They're non-superimposable mirror images, and we call them enantiomers. So all of you guys should know this from before. We've talked quite a bit about these. These are non-imposable super mirror images, and you have to have a carbon that has 4 different groups attached to them, and we call them either D or L, and so on and so forth. Okay, so it turns out this is the same thing. We call them enantiomers or non-superimposable mirror images, right? So again, just like our hand and so on and so forth, this is the mirror plane of the mirror, and B is close to the mirror, and we write B close to the mirror. Here is D is away and D is away, and so on and so forth. Okay. All right. So if you look at glyceraldehyde, the first molecule that we'll talk about is called glyceraldehyde, right? That I want you to memorize. Now, remember in lipids we talked about glycerol, right? So glycerol was this guy here. It is 3-carbon compound. If you remember, had OH, had OH, had OH. This was glycerol, right? So if I ask you, is glycerol a sugar? Is this guy a carbohydrate? Is it a sugar? Right? And the answer should be no, it's not a sugar, because there are 3 hydroxy groups, so it is polyhydroxy. That's true. But is it an aldehyde or a ketone? And there's no aldehyde, no ketone, but no aldehyde group or ketone, right? A ketone, and that's why. Oops, that. And that's why it is not a sugar. So it is not a sugar. Okay. All right. So, but if you talk about glyceraldehyde, now this is glycerol. Okay. Now glyceraldehyde is slightly different. It's based on glycerol as well, but the end is aldehyde. This is aldehyde group, and this is OH, and this is OH. You have H and you have H2. Right. So this guy is glyceraldehyde. It's glycerol with aldehyde. Glyceraldehyde. Okay, it's an aldehyde group with 2 polyhydroxy, and that's what's shown here. This is glyceraldehyde, right? And you can see it has an aldehyde group and 2 hydroxy group and aldehyde. Now, what you can do, you can actually put a mirror in between, and you can find this carbon is chiral. It has 4 different groups attached to it, 1, 2, 3, and 4. So this is a group. So this is a group as well. That's a group as well. This is a group as well. So it has 4 different groups. 4 different groups attached to it. It has a chiral center, chiral carbon, and you can write a mirror image, which is shown on the right hand side. Now, in this case, they're saying if the OH on the stereocenter is to the right, and this is again pretty important. Make sure you understand this. So if the OH on the stereocenter is to the right, like this OH is to the right, right? Then we call it D for dextro or D for right. It's called a D isomer, right? So that's why we call it a D isomer here. And if it's on the left, then we call it L for left, right? So in this case, OH is on the right, we call it D. So this is, because of this, it's a D isomer, right? And here OH on the left hand side, this is the L isomer and D isomer. Okay, so we call it D glyceraldehyde, the one on the left hand side, and on the right hand side we call it L glyceraldehyde. Okay, so same thing here. So again, you look at the OH on the right hand side, we call it D. OH on the left hand side, we call it L, and it's 3 carbon with aldehyde polyhydroxy. This is glyceraldehyde. So it's really important to memorize the structure. So this is number one that we're going to memorize, and we're going to have a whole bunch of structures, but they're not difficult. You'll see that it's fairly straightforward. Okay, so that's for glyceraldehyde. You should be able to draw L and D. Of course, the point is that this is the plane in the mirror, plane of the mirror. Okay, now we'll talk about when you have stereoisomers. It turns out we can have many stereoisomers. They have different number of stereocenters. So, for example, if you look at this guy here, this is 1, 2, 3, 4 carbon compound, and is this carbon chiral? And the answer is no, it is not chiral because you have 2 hydrogens. So again, for chiral, you must have 4 different groups. So although you have OH as one group and this whole thing as one group, but you have 2 hydrogen, that's not a chiral center. But this is chiral, and this is chiral. Is the top one chiral? No, this is not chiral either. This is not chiral either. It has only 3 groups. So if you have, and you can put a mirror image, put a mirror plane, and you have mirror image here and mirror image here, and this guy, if you look at, has OH on the right hand side, we call it D. OH on the left hand side, we call it L. Right? Now these are called enantiomers. As we talk about, enantiomers are stereoisomers that are mirror images. So this was a this was a compound, and you make complete mirror image. So there is a complete mirror images, right? And that's what we call them, enantiomers. So that these are called enantiomers. Okay, so likewise, this is another compound, and don't worry about the name, erythros and threos. But if you look at this guy here, for example, you have 1, 2, 3. So it's a polyhydroxy. This is a aldehyde group, and you have 1, 2, 3, 4 carbon. So it's a tetrose, right? It's a tetrose, and it's an aldose, and we combine them together. We call it a tetraaldose, right? And the proper name is called D-threose. Now, if you take this guy and you make a complete mirror image where OH is close to the mirror, you put OH here. H is close to the mirror, you put H here, and OH is away from the mirror, you put OH on the other side, right? So if we make complete mirror images, these are also enantiomers of each other. So this guy and these guys are enantiomers of each other. Okay, now remember a question is, if you have, this is a chiral OH, this is a chiral OH. Now one of them is on the right hand side and the other one is on the left hand side. So how do you know this is D or L? Remember we said we call it D if something is, if the OH is on the right hand side. So that's true, but the slight modification to that rule, we look at, so please pay attention, right? We look at the OH which is most far away from the carbonyl. So where is the carbonyl? This is the carbonyl, right? This is the carbonyl. So let me highlight it. This is the carbonyl. So which OH is most far away? You have this OH here, and then you have this OH. Now this OH is not chiral. So we look at the chiral OH most far away from the carbonyl. So this is the guy which is the chiral OH most far away from this, and that is why we look at this guy on the, if it's on the right hand side, is D, right? And if it's on the left hand side, it is L. So we don't look at this guy here, we don't look at this guy, we look at this one. This is the most far chiral OH from the carbonyl. So hopefully that makes sense. Okay, now so we talk about enantiomers. There's a different stereoisomers called distereoisomers. So distereoisomers are stereoisomers that are not complete mirror images, right? So they have, not all the chiral centers are opposite of each other. So for example, if you look at this guy here, you have D-erythros and D-threos. Again, don't worry about the names. We'll come back to it later. But you have 1, 2, 3, 4, and then you have 1 hydroxy, 2 hydroxy, and aldehyde. So it's a tetraaldose. It's a polyhydroxy aldehyde. So it's a sugar. Now, if you look at this guy, erythros and threos, if you look at the difference between them, OH is here, OH is here. So these are again the right hand side, so we call it D. They're both D, they're both D. But this guy, it is not a mirror image. If you had a mirror in between them, this there should be something here, right? Now this guy is mirror image, but this is not, right? So they're not superimposable, yet they are stereoisomers that are not superimposable, right? So in this case, um, we call them. Let me erase this part. Okay, so in this case we call them stereoisomers that are not superimposable, right? So they're not superimposables, but they are stereoisomers, meaning they are right L or D. You know, they have this. So we call them distereoisomers. So, so again, we'll talk more about them a little bit later. It's a little bit confusing, but please make sure you understand it. The book talks about it a bit more, and there are internet resources as well. Okay, so we've talked about two things. We've talked about we say enantiomers. These are, you know, complete mirror images, right? Okay, we call them distereoisomers, which are enantiomers, which are stereoisomers, but they're not mirror images, right? Um, and then there's another word we'll talk about epimers. Epimers are compounds that are only different at one stereoisomer, not all of them, just one, right? So you can have distereoisomers who are epimers as well in the previous slide. But so let's see a bit more. Okay, now shown here is an example of distereoisomer. Here is an example of enantiomer. Here's an example of epimer. So let's look at one by one. Okay, so we said distereoisomers are, so let's do this one. Enantiomers are complete mirror images. So if you look at this, you know, L-glucose and D-glucose. So this is aldehyde group here, aldehyde group here. It has chiral center, chiral center, chiral center, and chiral center. It has 4 chiral centers. This is not chiral, and that's not chiral. Okay. Now we look at the chiral OH most far away. From here, we'll go down, down. This is the most far away. It's on the right hand side. We call it D. Now D-glucose, if you have a mirror in between, and if you look at this and this and this and this, they're exactly mirror images. So if they are mirror images, then we call them enantiomers. So enantiomers are complete mirror images. Okay, now if you have distereoisomers, we say distereoisomers are stereoisomers that are not complete, you know, so they have at least 2 stereocenters they are different and. So for example, if you look at this, you know, if you look at these are mirror images, right? But this guy and this guy are not, and this guy and this guy are not, right? Now again, if you look at the most chiral OH, which is, this is the most far away chiral, this is on the right hand side, we call it D. It's a D-glucose. So we say D-glucose and D-altrose are stereoisomers because they are different from each other in stereocenters, but they're not enantiomers because they're not mirror images. Yet they have at least 2 chiral centers they're different in, not one. If it's only one, we call it epimer. So epimers are only differing in only one stereocenter, right? So only one of them is one of the stereocenters is different, which is this one here. So if only one is different, we call it epimers. Only one, right? If we have more than one, but not all, if all are superimposable, we call them enantiomers. But if there are more than one, then we call them distereoisomers, right? So please, this is a little bit confusing, but please make sure you understand this and spend some time looking at it. There's some online resources that talks about it as well, and then the book talks about it as well. Okay. So let's see. So you can. This is again some structures that they're showing you. This is 1, 2, 3, 4 carbon. So this is a tetrose. It has an aldehyde here. It's an aldotetrose, and the specific name is erythrose, D-erythrose, and it's called a D because this is the chiral OH most far away. It's a D. It's on the right hand side. It's a D. And here again, if you look at this, this is the chiral center on the right hand side. It's also a D. this is a ketone, so it's a ketohexose because it has 6 carbons. It's a ketohexose, and the proper name is D-fructose. And we'll talk about this a little bit later. But so you can show glucose, carbohydrates, sorry, or monosaccharides as a linear chain, straight chain, linear chain or straight chain, and we call them Fisher projection or Fisher structures. Fisher was a scientist, so this way of writing structures are called Fisher projections. Okay.